Okay, so today we're going to be working on combinations. Yesterday we worked on permutations. Permutations have order, okay? So if you're looking at something, race or something like that, it may be like first, second, and third, okay? Combinations have no order, okay? So the difference between like first, second, and third is something like top three. So finishing in top three doesn't matter if you finish first, second, third. It just matters if you finish in the top three overall. Okay. And the way we do a combination, the permutation was a P. It was all options over how many you want, or the number you want. Okay. With a P in the inside. This one's just same thing with a C. All options, and then the number you want. Okay. So we'll do a whole bunch here of combinations. And as I said before, get a piece of paper out, get a whiteboard marker, get something on here because I'll just give you questions and I want you to try to solve them yourself as we go through. Okay. So, 12 people in a race. How many gold, medal, silver finishes could there be in that order? Gold, silver, and bronze. Okay. That would be, there's 12 options. We have order or roll, so it's going to be 12P3. If I do that on my calculator, 12P3, that's going to give me 1320, 1,013.20. Okay. Now, how many groups of three can finish on the top three? Groups have no order. Okay. So that's going to be a combination, as in 12C3. And we do that on our calculator the exact same way, 12, and you have an NCR right here, C3, 220. A lot less. Okay. Because if you think about it, if it was like, let's say it was like Mark, Stephen, and Gabriel, first, second, third. This is also a different order. First, second, third. Then I could also have, let's see, Stephen, Mark, Gabriel, and then Stephen, Gabriel, Mark. Those are all different. Then I have a Gabriel, Mark, Stephen, or Gabriel, Stephen, Mark. Right? Those are all the same. Those are all different. Those, in terms of combination, all of these are the same. It's just three people finishing in the top three. Okay, so this is all the same in terms of combinations. Okay, now we could do something here. Let's say there's 30 people in a class. Okay, there's 30 people in the class with no restrictions. How many president, vice president, and secretaries could we have? Those are three distinct roles that exist. So for this one, it's going to be 30P3. Now, if I was looking for a three-person committee, the committee has no roles. So it's just going to be all together. So that's going to be 30C3. Okay? So there's a difference between having roles and not having roles. Okay? Let's go down here. Let's try to make it a little bit harder now. So Mr. Ann says the coach of the co-ed ultimate team. He must select 6 players to start the game. His team consists of 10 females and 9 males. How many possible starting lineups could there be? Well, in sports, when there's a starting lineup, it doesn't matter. There's no order when you go out, essentially. There might be positions, but essentially there's no order, so they're all going to be C's. So I have 19 available between the 10 and the 9, and I need 6. So it's going to be 19C6. Now, as I go through this, I'm not going to calculate it every time, but on a test, I am going to expect you to calculate it. 27, 1, 2, 3. Give me both answers. Okay. So how many starting lineups can be achieved with 3 females and 3 females, 3 males. Okay. So still the same thing here. In this case, this is going to be my female batch, and this is going to be my male batch. So I have 10 females, and I want 3 to start. And I have 9 males, and I need 3 to start. So that's going to be my answer there. Now, how many starting lines will have 2 females and 4 males? And you're essentially going to set up just like we did before. And I encourage you as I go through this to pause the video, see if you can get the answer, and then come back to it. So I have 10, and I want 2 females to start, and I have 9 males, and I want 4 to start. If we were doing that, it'd be 10 C2 times, 9 C4, which is 5,670. Now, how many of the starting lines will have only females? Okay, my only females, I'd have 10 options for females, and I'd have 6 go. And that would be my answer for that one. Right. So Mr. O must construct a committee to review his teaching skills in math. There are 10 people in the class. He must make a committee of 3. So that's our options. We have 10 total options. And I need 3 there. Okay. Combinations is really good to work with cards as well. Because when you're playing cards, it doesn't matter what order the cards get into your hand. It just matters that the cards come into your hand. Okay? So we're going to use cards for a bunch of combination stuff. So some notes about cards if you haven't used it. You can take a little picture of this or make note of it. There's 52 cards in total. 26 red, 26 black. There's 4 suits. Hearts, clubs, diamonds, spades. There's 12 face cards, which are the king, queen, and jack. Ace is not a face card or a number card. And there's 13 different cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, king, queen. All hands I talk about have 5 cards. Okay. So how many hands could be made with no restrictions? No restrictions at all. So if you think about it, I have 52 cards altogether. How many do I need out of there? I need 5 cards. So that's my, how many can I make? Just 5 cards. Now, how many can I make with all red cards? Well, I have 26 red cards, and I need 5. Remember, it's all options, and how many you want. Okay, then how many will be all hearts? How many different ways could I make an all hearts hand? Okay, all hearts, I have 13 hearts, and I need 5 of them. Right. So now, how many will all be the same suit? So that means all hearts, all diamonds, all clubs, or all spades. Okay. So the way I do this is I'll do one of them, 13 hearts, let's say. I need 5. Now, how many different ways can I make that? I can make it 4 ways. So I have 13 of each suit, but I can do this 4 ways. I can do all spades, all hearts, all clubs, or all diamonds. Okay. Now, and I'll do a separate video, just tons of card ones later on. How many will have 2 kings? Only 2 kings. So it's going to have 2 separate sections. This is going to be for my kings. This is my other cards. How many kings are in the deck? There's 4 kings. I want 2. Then of the rest of the cards, once I have 52, I take out my kings. I'm left with 48. So I have 48 cards left. So I'll multiply between them. Then to fill my 5, I need 3 more cards. So, sorry, I got a little bit of cold. How many will have at least one pair? So any pair, we go here. So if I make any pair, there's 4 cards of each kind. I want 2 of them. Okay. Then there's 13 ways I can do that. I can do it through aces, 2s, 3s, 4s. So I'm going to times this by 13. Then I have 48 cards left, and I need 3 of those. Okay. Now what I want this time, last one, is I want a pair of 1 cards. Let's say a pair of 2s, and then 3 of a different kind. A pair of kings, for example. So a pair and a 3 of a kind. So I make my pair first. 4C2. There's 13 ways to do that. Then I'm going to make 3 of another one. I'm going to 4C3. That gives me 3 of something else. I have 12 left of those. So pretend I got 2. Well, same thing. I got 2 2s here. So then I go through it again. I only have 12 options to make 3 of a kind. Right. So that's it for today. You have some practice there for you to work through, and we'll go from there.